So we're going to start on trigonometric functions today. So there are 3 trigonometric ratios below that can be used on a right triangle to find the missing side or angle. We can do it either way. These are not the only 3. There are actually 6 of them, but we're going to focus on the first kind of basic 3. So we have sine, cosine, and tangent. So these are definitely ones, and you should have heard of these before. We've done these before in some of our IM classes. So if this is, it depends on if you're an IM1 or IM2, because we're actually both going to focus on these for a little bit. But we kind of hear about these through, I think, all of the IM classes at one point. So if we're looking at this piece, we do need to make sure that we're understanding that there's kind of a way to label these. So if you notice that we're looking at angle A on all of these, so we could look at angle A or angle B. We never look at the 90-degree angle. We only look at the acute angles when we're doing these trigonometric ratios. So in this case, we're looking at angle A, and the way we label this is the side opposite the angle, we literally call opposite, okay? So we have opposite, and then the side that is across from the 90, we don't call that opposite as well. That's actually the hypotenuse, and that is always the hypotenuse, okay? So if we find the 90 degree and you go to the opposite side of the right angle, that's the hypotenuse. The opposite side of the angle is called opposite. So then we have this third side, and what we call that is the adjacent side. And adjacent means next to. So if I say, the building adjacent to this one, I'm talking about the building right next to it. So if you can kind of remember that definition of adjacent, then it means, the side right next to the angle. So the hypotenuse and the adjacent side, they make the angle, okay? So understanding how we label this is going to help us when we go through and we do these, because we literally just plug these in. So sine is opposite over hypotenuse. And if I look at that, opposite is A and hypotenuse is C. So normally we're going to have numbers here, right? And I would just plug them in. I'd have A over C. And then cosine, that's adjacent over hypotenuse. So that's B over C. Oh, forgot my line there, darn it. And then tangent, that's opposite over adjacent. So that's A over B. So one thing to help you remember this, and it's going to sound funny at first, but it definitely helps remember, if you can remember this silly little saying, if it'll pop up here, I'll read this in just a moment, is SOHCAHTOA. So it sounds really funny, but it helps you remember all of this without having to actually remember the words opposite, hypotenuse, adjacent, hypotenuse. Now, you need to remember what they stand for, but it's sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent. So if you can remember SOHCAHTOA, makes it way easier to have this kind of memorized without having to constantly have it written down. So this is something I remember in high school that I would actually write this down just to help me remember how to do the trigonometric functions. So would the ratios be the same if we were looking at angle B? So if we switched and we looked at angle B instead of angle A, well, the opposite and the adjacent angles would actually switch places. Or not angles, sorry, adjacent sides. I should say sides, would switch places. The hypotenuse would stay the same. The hypotenuse doesn't move. But what I mean is, now if I'm looking at angle B and I go to the opposite side, well, now it's down here. This is opposite. And adjacent, the side right next to it, that's not the hypotenuse. The other side right next to it is the adjacent side. So opposite and adjacent switch places when we switch angles. Okay, so just be aware, opposite and adjacent can switch places, hypotenuse cannot. Okay, let's go ahead and apply this. So again, I brought the SOHCAHTOA down here so that we can see that pattern there. So we have a right triangle with sides 8, 15, and 17 as shown below. Use these lengths to find the tangent B, sine B, and cosine B. So here is my angle B. So I'm going to immediately go and start labeling. There's my opposite side. So my opposite is 15. My 90-degree angle here is C. So 17 is my hypotenuse, which makes 8, this other side, my adjacent side. Okay, I like to label opposite and hypotenuse first because they're, for whatever reason to me, the easier ones to label. And then adjacent's kind of the other one that's left out there. It's the other side that's next to the angle. Okay, so now that we have everything labeled, we're going to go through and we're going to start to apply our trigonometric functions here. So I always go in order of SOHCAHTOA for whatever reason. You can go out of order if you want to. It's not a big deal. I just always kind of hear it in my head, the SOHCAHTOA idea. So I have the sine of b is opposite over hypotenuse. So my opposite is 15. My hypotenuse is 17. So I have my ratio already, 15 over 17. And this is how Alex wants you to leave it. They don't want you to turn it into a decimal. They haven't given me any rounding instructions, so don't round. Okay. So now I have cosine, and that's adjacent over hypotenuse. So I have 8 over 17. So there's my cosine, 8 over 17. And then I have tangent, which is opposite over adjacent. So that's 15 over 8. So I have my 3 trigonometric ratios written out in fraction form. I hope that helped, and I will see you in the next video.